Hello everyone. Let's look into this problem and try to solve. The question says a block lying on a smooth surface with spring connected to it is pulled by an external force as shown in the diagram. This is your block, surface is smooth, no friction. This is the spring which is connected to the block, and here the force is applied to pull the spring. At an instant, the point velocity of point A 4 meter per second as per question, and for point B 2 meter per second. Another given information is if the energy of the spring is increasing at the rate of 20 joule per second, then the stretch in the spring is what? This we have to find out and select the correct option. So let that instant be t. At t we will be start working for it. The B point, the P point is directly connected to the block. Therefore, the velocity of block will be equal to velocity of B point. That is at t is equal to t 4 meter per 2 meter per second. Sorry, as the question it is 2 meter per second. At point A, the external force is applied. And velocity of point A is VA is given in the question 4 meter per second. So it means point A is moving faster than your point B in this direction. Because of this, the spring will keep stretching till the time the velocity of A and velocity of B becomes equal. But my question in question, it is being asked at time when the velocity of B point is 2 meter per second and velocity of A is 4 meter per second. So what is the stretch in the spring at this condition? So let us make the free body diagram of spring. At A, the external force is applied. So we should say it as for F subscript A. What will be the force at B? At B point. At this instant, there is already stretch. Spring is already having certain stretch. Let us say that is X. So its original length was, if we say L, At T is equal to P, it has become L plus X. So this FB should be equal to A into X as per Hooke's law. Nothing has been mentioned about the mass of the spring. Actually, it should have been mentioned. We are taking the mass as negligible, means almost zero. So from this diagram of the spring, if we write the force in the horizontal direction, the net force in the horizontal direction is FA minus FB is equal to mass of the spring. We are taking it negligible, means zero. Its acceleration. From here we will get FA is equal to FB. But FB is kx. With this information we got already. Now it is talking about the stretch in the spring. That means we have to find out this x. External force is Fa, and this force is delivering the power to the spring and block system. So whatever power the external force will deliver to the spring and to the block, we can write like this for that. Power delivered by the external force to the spring and block system is equal to power storing in spring plus power delivered to the block. There is no other place where the energy is passing through because surface is smooth, so no friction. So only in the spring and the block the power is getting transferred. So how will you write this power due to the external force? That will be Fa dot Va, velocity of point A. Power storing in spring, as per question, it is 20 joule per second. Let me give a little gap to it. Our external is power due to the external force. We can write Fa dot Va. Power storing in spring is 20 joule per second as per question. Power delivering to the block is the force acting on the block. Since on spring it is Fb, so equal and opposite force on the block will be FB in this direction, FB dot VB. This force and the velocity is in the same direction, so we can write this as FAVA cos 0 degree, that is 1. This one is 20. Force on at B on the block, or force on the block, and VB is in the same direction, so we can write FB VB cos 0 will be 1. Bring FB VB on the left hand side. We have already got here FA is equal to FB is equal to Kx. So we can replace FA and FB by Kx. K into X, VA minus Kx VB is equal to 20. Take Kx common. So this will become VA minus VB, that is 20. So your X will be equal to 20 by VA is 4, VB is 2, and K is 100 Newton per meter. So this becomes 10 by 100, that is 0.1 meter. To convert that into centimeter, you will have to multiply it with 100. This is 10 centimeter. So stretch at that instant when the velocity of point A is 4 meter per second and velocity of point B is 2 meter per second is 10 centimeter. Let us go and check the option. C is the option where the stretch has been shown as 10 centimeter. So our answer will be option C. Hopefully you understood the concept of solving it. In case of any doubt, please do write in the comment box. I will clarify the doubt. Thank you.